let me plug in the numbers here, it will be more clear. So N is 2. Now, do I need to write the units moles? Well, personally, I don't, because we work with, probably by now you're familiar with my style. I work with SI base units, right? It's the MKS system. There's meters, kilograms, and seconds. If you work with SI base units, everything you plug in here, if it starts off in SI, it ends up in SI, okay? So if everything I plug in is made up of SI base units, what I just need to know the SI base unit of the final thing. What's the SI base unit of work? Someone can put that in the chat while I do this. So that's my technique. So one other thing you need to remember is moles and Kelvin is also SI base unit that is relevant for this course. In total, there's 7 base units in the international standard system, the SI system. But the other 2, very little people care. In fact, MKS gets you most of the way. Okay, so so I'll just plug in 2. You'll see that it should work for itself. And 8.31 is the universal gas constant. I remember that. You don't have to worry about, is that ATM per Celsius or, whatever. Or 8. That is the SI units, so it's joules per Kelvin and stuff like that. And T, what do I plug in for T? 25, right? No, because as I just mentioned, you need SI units in here, right? So you need to have this in Kelvin. So that's what you plug in over there. And then you multiply by the way, my strategy personally is very simple. When in doubt, use SI units and guarantee it will correct. It's 100% and it will work. Now, if you know shortcuts that you don't need to convert things to SI units, for example, in MC delta T, you don't need to convert that to Kelvin. If you know that, that's fine. If you're not sure, you do it this way, it guarantees it will work. And then that's 0.5, because that ratio, as I just mentioned over here, you make that explicitly clear. Right, so that is 75. All right, so you plug this in, you hit equal, so that's what you get. Let's worry about the minus sign last, right? So something like this, right? First of all, units, what is it, right? So work is the SI base unit for it is joules. Joules is basically just made out of MKS units. All right, so now we'll worry about the sign as well. This is not the final answer, so we'll worry about that. How do I figure out the sign? This is how I think about it. So there's 2 choices. It's either positive or negative, but you need to worry about who's doing the work. Is it gas? Is it the work done by gas on the environment, or is it the work done by the environment on the gas? If one of them is positive, the other has to be negative. Okay, so if the environment is doing work on gas, then the gas is receiving the energy, right? So if the environment is doing the work, putting energy into the gas, it's doing work on the gas, then the gas is. So negative work done is very hard to imagine. So this is a way to imagine it. So if you see negative work done, just think of it as receiving the energy that is done by someone else. Okay. So how do I know which one's which one's positive? So now the gas is it's being compressed, right? So in your mind, is it the environment doing the work on the gas, or is it the gas doing the work on the environment when it's being compressed? So if you're being squashed, are you doing work to the environment, or is the environment doing work on you? Right? The environment's doing work on you. So environment on gas is positive. Gas on environment is negative. So the gas is not doing, if it's the other way around, if the gas is doing work on the environment, then the gas will be pushing out. It's doing the work, right? It's giving the environment energy. The environment's receiving that energy. And so the environment would be negative, the gas would be positive in that case, but here it's a compression. So the environment doing it's positive. So which one is it asking for? So we're asking for, the aim is, see how good it is to have this right by your side. You don't have to look back to the question, right? So stating the aim is good. Work done on gas. Okay, which one's on gas? This one, right? So I need a positive number. So just don't write this. This looks weird. Negative equals positive. Right, so start another one. So work done on it's positive. Let's do the correct significant figures as well. I think it's roughly 2 6 everything. All right, so that's the final answer, something like that. So hopefully I have dissected out. The black bit is a specific problem specific. So Well, if you ever find physics, I hope in these sessions I'm also showing you how to go through physics problems, right? If you find physics problem difficult, there's a good reason why people find physics problem difficult, because there's several parts to it. There's a part where you process the information, a part where you dissect the physics and set it up correctly, and then a part where you plug in numbers and then deal with all the annoying things like units, significant figures, plus or minus signs, and also calculator algebra. So there's three parts to everything, all physics problems. And if you're just a master of plug and chug, you're just a master of this part, and you're constantly seeking this magic formula over here so that you can plug in the numbers, then you're only skillful in 1/3 of the problem solving procedure. That's why people find it difficult. You're missing the other 2/3 of the skills. So here, following what I've given you, my system, or this is my way of solving it at least. I don't know if it works for you. I've heard that it works for a lot of people, so I hope it works for you. It's not a magic pill that helps you solve the final answer. In particular, it doesn't help with this part at all, but it helps with the first 2/3 of it. So if you ever have trouble doing physics, I would wager a large part is you're having a deficit of skills in the first 2/3 of the problem solving procedure. It's not the last bit. If you find this magic formula, yes, it's annoying to find the correct numbers to plug in. Yes, you need to worry about which units. Yes, you have to worry about signs, significant figures, all those details. But I think you have the skills there. You know, those are nitty-gritty things. And that's why I hope you tolerate some of the longer discussions I have with these. Now we'll move on to part B. Good.